yeah, I wanted to start with this question we were discussing a bit earlier. Why a vote on Gather's metaverse and not just a Zoom meeting? Why? I'll answer this question by mentioning a DevOps concept. The products that you build are defined by the structure of your organization. And in our case, it's not an organization, it's a community, and it's completely up to us to define, what are our products. But I think it still applies because LinkedIn, as a social network in general, dictates a structure that ultimately centers on following, subscribing, liking, monetizing. And yes, there's a sharing button, but there's not a real sharing philosophy. And we either produce or consume content. For me today, I'd like you to think of this space, of our space, our floating metaverse, as an opportunity for us to build together a space where we can share and build together. And it's not only possible to do so, but also in everyone's best interest. So thank you everyone again for being here. And with no further ado, please let me hand over to Christian. Christian is MLOps engineer specialized in NLP. He is based in Germany and he's working for Diamond Software. Thank you, Christian, for accepting our invitation, and over to you.
Yeah, great. Thank you. I hope everyone can hear me okay. Let's give it a shot with the screen share, and then I'll start the presentation. Everyone can see the slides, I hope. Just notify me if not. Okay, great. Yes, introduction to MLOps. Let's talk about it. So I'll be providing in this presentation, yeah, just a really high level. Yes.
Sorry,
yes.
I think you're not on the spotlight, so they don't hear you.
Okay, give me a moment.
Just go next to the mic on the stage.
I have to go here and then walk like this.
Exactly,
right?
Here you go.
Okay, sorry. Great, and then I want to go here. Can I end the screen share, start the screen share? Okay, great. I think that's what I want. Just notify me if anything is not working technically. Okay, yeah, so as I was saying, this is really a high-level overview of some concepts and technologies. I'll also do a quick demo of a simple setup, but we might not need the whole slot depending on how much discussion is required. I'll start with a little bit about me personally, just to give you an idea of where I'm coming from before getting into some key concepts. What is MLOps? Why do we need it? What are some unique challenges and concepts? Then we'll wrap up with example projects as mentioned. So first, a very minimal setup, and then at a very high level, just talking conceptually, I'll show you a bit of a more intermediate project before providing some additional resources in case you'd like to dive deeper. All of the code and slides from this talk will be available after. So as Sherwin mentioned, I currently work at a company called Diamond Software in Germany, where we apply AI to automation of accounting tasks. There I'm responsible as an MLOps engineer for design, implementation, and maintenance of our machine learning infrastructure. On the side, I have experience with computational linguistics and cloud solutions architecture from previous roles. MLOps. What is MLOps? If you attended the talk yesterday, where Joshua gave a very comprehensive overview of DevOps concepts, you would probably be familiar with this Venn diagram on the right. In general, we can think of MLOps as a specialized form of DevOps, which tackles the unique challenges posed to operations by machine learning applications. So in the diagram on the right, you see some of the delineations of relevant skills and responsibilities. DevOps focusing more on configuration and infrastructure as code. LLM ops, which we'll hear about later, obviously requiring skills specific to the requirements of LLM applications, and MLOps spanning some common functionalities of both CI/CD. Monitoring evaluation is critical for any machine learning model, and more specifically, model versioning, feature engineering. In a way, these delineations of this kind of Venn diagram is somewhat arbitrary. It really depends on your organization and the constellation of MLOps engineers, ML engineers, data scientists, etc., roles that you'll have on board. So for example, in my current role, like I'm also involved in some IAC and software development. It really depends on, what is in your organization and how you need to distribute the capacities, but we can roughly conceptualize the roles like this, and we'll get a better sense of what MLOps engineers may be called to perform when we take a look at some key technologies. One can also consider an MLOps engineer as a central point of coordination for other roles. In my role, for example, there's a lot of communication between data scientists and product. So the communication, let's say, skills of this role can't be understated. In general, the unique challenges of MLOps can be focused on machine learning models as a unique service artifact that is required in AI-based applications. So in many respects, a machine learning system is not that different technically from a non-machine learning system. One still needs to expose scalable service with defined communication interfaces, maybe a persistence layer in the back. DevOps is, of course, also important as implied by the Venn diagram. But what is especially unique about MLOps applications is that they often have at their heart, of course, a machine learning model, which needs to itself be versioned, managed, deployed, and monitored or evaluated in a unique manner. So this, to me, is like the most kind of specialized part of machine learning apps, which necessitates unique discipline for its operations. We'll take a look at model versioning, deployment, and monitoring later as well. This final diagram emphasizes again my point about the central coordinating capacity of machine learning engineer, or in this diagram, MLOps engineer, often needing to coordinate and align expectations and tasks between, for example, a data scientist and a data engineer. So there's not only some overlap in skills, but there's also demand for communication there. Yes. On the right here, as a continuation of the point I was making earlier, I have a diagram of a simple 3-tier application architecture, and also a summary of typical DevOps workflow. I believe Joshua also used this diagram later. If you want more details on the concepts from his talk, please refer to his presentation details. But the main idea I'm trying to convey here is, in a way, MLOps is, as mentioned, a discipline just derived from the unique requirements that arise if we add a machine learning model to our stack here. So of course, in any like application like this, we are going to have some presentation layer and our application layer, which demands versioning, building, testing, and operation of that application. Maybe you also have some versioning with respect to your database schema on the back end. But if we add to this a machine learning model, we can imagine that we have an additional set of operational workflows that now rest atop our DevOps workflows and are specialized to the requirements of the model. So here is the MLOps pipeline, so to say. Of course, if you are deploying a model, you need data for it, and you would also likely need some data analysis in order to understand how your data looks, what kinds of models are best, etc. And for EDA, it's often advisable to have, for example, tooling such as experiment tracking. Data preparation is obviously critical, and therefore some kind of data versioning, for example, tool can be relevant. That goes more in the direction of data engineering, but is nevertheless relevant. Training, which is a process you probably want to automate, implies some automation tooling, which is certainly relevant to the machine learning lifecycle, as well as evaluation. Let's say new data comes in, you want to see how your model is performing now against that new data. So there's a demand there as well. Release and deployment of the model is maybe not so interesting from a, let's say, like unique perspective, but often machine learning models will have unique requirements for inferencing. Maybe they need to be attached, depending on their size, to accelerated hardware like a GPU. And in that case, maybe you need to handle the incoming requests in a specialized way, batching of requests so that they can be passed to the GPU in a single step. There are all kinds of optimized inferencing engines for various types of machine learning models. And so in this case, the operation of the model is especially unique, as well as monitoring. In cases of a model, we often want specialized metrics which are relevant to the use case or the particular type of model which is being deployed. And so one sees that generally in terms of the operationalization of just one additional service component, your machine learning model, you come across a lot of additional requirements and potential complexities, which motivates the notion of MLOps and the specialized technologies relevant to the discipline. Just an overview of some of these high-level concepts I touched on there. Really quick, experiment tracking systems for keeping track of all of the experiments. Often this will be used by data scientists, and then the output of experiments can be transitioned into production. It's relevant to the EDA step on the right here. Workflow orchestration, as mentioned, whether it's for automated training, maybe also for data preparation and or model evaluation, is certainly helpful as a kind of generalization of scheduled workflows, which nevertheless may have special requirements for a machine learning model. Often you need to be loading a lot of data, maybe spinning up a compute resource on demand, training the model, and then dumping that artifact somewhere so that you can deploy it later. All of this plumbing could lead to a lot of complexity unless you have a tool which handles it for you. We'll talk about that later. Model registration. Let's say you train one model and then next week you want to train another model and you want to have a way of staggering your deployments relative to the versions of your model in just the same way as you need to, or you, according to DevOps best practices, version your code base so that you can keep track of your changes. Models are ideally also registered, versioned, and tracked in a way which makes sense and also associates those model artifacts with, let's say, the data they were trained on, maybe the metrics that are associated with a particular evaluation of that model. As mentioned, model serving has specialized requirements, and performance monitoring. Maybe we just care about throughput of our service, but in particular for a machine learning model, especially if you have some kind of feedback loop where users can provide so to say, ground truth labels for any prediction. It's especially useful to see how your models are performing in real time in case there's, so to say, drift. On the right, I have a lot of pictures from technologies which I'm familiar with and may or may not be relevant to an ML operational stack. But you could just as well fill up 2 more slides or even more with other technologies. So there's a lot out there that you can work with. But I'll be focusing on these because I have experience with them and they serve to highlight a lot of the key concepts for machine learning operations. Let's go through them. Data collection. As mentioned, obviously the data is probably the most important component of your machine learning system because higher quality data leads to higher quality models. And so the manner in which you collect that data is of important concern, not just that you can do it and store it in a nice way, but that however you're collecting is scalable. You may offer a RESTful interface, or often a streaming technology is relevant if there's some kind of continuous loop. And on top of this, some notion of versioning with respect to where you put that data is often useful when you are iteratively training new models as new data comes in. So on the right, I've listed RabbitMQ and Kafka, 2 event-based communication tools, which can be useful for data ingestion. Experiment tracking, as mentioned, is important to the machine learning lifecycle in order to structure the collection and execution of machine learning experiments and make more transparent their results. So it's as much about keeping track of everything as it is about collaboration and making it easy for the team to share results. On the right here, I have MLflow, which is very popular and solves other challenges in addition to experiment tracking, but also model registration, which we'll talk about in a second. Sacred is another tool, which is maybe less widely used, but is also quite nice. In general, the goal here is to track experiments and their artifacts. Maybe there's a chart that your experiment has output or some metrics. And maybe you also want to be able to aggregate results over a larger swath of experiments you've done. They can also be used for not just ad hoc experiments, but automated evaluations, so to say. As a next step from this, let's say your team has done a lot of ad hoc experiments and evaluated different models and found a certain type of model is really good for this use case, and you move more into optimization of the selected model. It's advantageous to version your different iterations of that process as a preliminary step of organization before deployment. Yes, this also supports automated deployments. And with respect to the technologies on the right, MLflow, as I stated, supports model registration in addition to experiment tracking. And there's an integration between these 2 components of that platform, which we'll take a look at later. I call it here training systems, but as mentioned earlier, you can think of it as just general workflow orchestration being very useful, if not necessary, especially to highly automated machine learning systems. So on the right, this would be Airflow. This is one technology which I have some experience with and will also see later. But as mentioned, given the demands for training machine learning models, maybe large models or maybe in an automated fashion, there's a lot of plumbing that is required, connecting to data sources, loading, dumping, training, outputting artifacts, logging, evaluation scores, maybe spinning up a compute instance, etc. That is probably implementation that you don't want to do all yourself. So the more one can rely on some tooling in order to handle the orchestration, the better. Serving, for this, there are really a lot of tools, especially open source technologies. If you're working in the cloud, you'll probably even have access to more abstracted serving providers where you don't need to think so much about the underlying technology, but for example, can just provide an Onyx model and let the service of choice make an endpoint for you. If we're talking about technologies which you can adopt yourself, maybe open source technologies, here I have ML Server from Selden. This I'll also show in the demo, and TensorRT, Triton, these servers from NVIDIA are very popular for their performance, especially with models which require GPU hardware. Yes, so in this case, optimized serving kernels can be especially critical when you have GPU-reliant workloads. I mentioned batching capabilities earlier. Finally, in terms of observability and monitoring, it may not be the case that a specialized technology for machine learning is really required. Let's say, machine learning specific requirement may more lie on what metrics you're configuring, what data you're storing in whatever persistence is backing your dashboarding or observability tools. But on the right here, I put a couple of technologies which I'm familiar with. Joshua mentioned Grafana and Prometheus yesterday. This is a great ecosystem for monitoring. Depending on the nature of your application, you could also export some metrics which are more relevant to machine learning, although this is not strictly the intended use of that observability tool. On the other case, build a Plotly dashboard yourself, or Metabase is also a nice tool, I find. If you are storing model-related performance data in a database, you can easily mock up dashboards with that. Yes. Now we move more into the, so to say, practical part of the presentation. And apologies for talking so long. After this next step, we can pause a little bit if there's any room for discussion or questions. But first, I'll get through a, so to say, minimal MLOps project with a few important tools. MLflow, as mentioned, is quite popular and provides solutions for experiment tracking and model versioning, model registration. And Airflow, so another flow, which provides solutions for workflow orchestration and a lot of out-of-the-box connectors, which can really simplify a lot of the plumbing associated with training and maintenance of machine learning systems and or data engineering. Finally, ML Server, which, as mentioned, is a somewhat machine learning optimized serving package with a lot of quality of life features to make it easy to get up and running with a variety of popular training or modeling libraries. And I'll give you a sense of that as well in the demo. This is just a minimal project. And the main idea to convey here is this kind of end-to-end loop, going from training experiment tracking to automated evaluation and then inferencing. So keep this in mind as I go through this really quick demo here. But what I've tried to provide is a, so to say, complete small system whereby one could implement a minimal MLOps workflow, going from training to evaluation to eventually deployment. Yes. Bear with me, I pre-recorded this footage, so I think on your screen you might have a little zoom in tool where you can take a closer look. But after going through this prepared demo, we can also just look at particular configuration snippets or even play around with some of the services. Let me just start this up, and please do notify me if anything doesn't work correctly. In this repository, which as I mentioned will be made available after the talk, I provided a few Docker compose files for setting up a minimal stack with MLflow and Airflow. You'll notice, of course, there's not a lot of code here. As I mentioned, if you choose the right technology, hopefully you don't have to do a lot of implementation yourself. Let the tools do the work. Here is a simple script which, among other things, pulls the Airflow Docker Compose and then starts up a few other compositions which are also included in the repository. So here we see, after running it, we're starting up some Airflow containers and also a few other containers, including our MLflow service. Great, everything's started. Next step is to check if everything's running. You see here that that Airflow web server with one of these workflows configured. Let's take a moment here to explain a little bit of what Airflow is doing and what this is on the right if you're not familiar with Airflow. Maybe it's a little confusing. Airflow is just a way of automating workflows. Airflow calls it a DAG, like a sequence of things you want to do. And the way that you configure this is with a Python file, which you see on the right. We don't need to get deep into the syntax of the configuration, but at the end of the day, this tool is just like a cron job on steroids, allowing you to automate some workflow. And in this case, I just have a single step, and it trains an sklearn model and then registers it to my MLflow. So the automated training and then the experiment tracking. Taking a quick look at that Airflow file, we see there's some calls to the MLflow client and also some sklearn code. Let's start it. And you should see, this is just some logs being output by that job. What's nice about Airflow is it gives this graphical interface where you can see all of the stuff very easily. Now we're in MLflow in the experiment and logging. We don't have an experiment right now because it's not done. But after a few moments, when the workflow, which was manually triggered by Airflow, it could have been automatically scheduled, is finished, we have a new experiment registered in MLflow along with the model. So here's our sklearn model, which we just trained. Now we see the integration between experiment tracking and model registration. So here, just creating an arbitrary model of, it's the first version of it. MLflow handles schema and all of this for us, which is quite nice. Okay, we've gone from the automated training to the versioning. Let's talk about deployment. What I'm showing here is a configuration file for ML server, which, as mentioned, is serving technology which offers some quality of life features. Again, we don't have to write any code ourselves. We just do a couple of config files and press run. So here you'll see configured the server port to 5555. ML server nicely provides a Swagger docs. So let's check that out really quickly. But unfortunately, it's not working. It's not working because we trained the model, but our server doesn't know how to find it. So quickly checking back into our composition and our ML server container, we see, yeah, it couldn't find the model with this model name. Just an FYI, if you pull the code and try to run it yourself, you would have to change the parameters here. So as mentioned, luckily we can work only with the config files. It's very easy with ML Server. We just say, use this MLflow runtime and use this particular model, and it will load it and serve it for us. But if you're trying to do this yourself, you will have to adjust this URI here. So our model we called test, and it's the first version of it. Now we restart the container. Great. Take another look. This is another nice thing. You get all of these Swagger docs and all of these different endpoints free of charge. So health endpoints. You can get a list of all of the models that you're serving. You can possibly serve multiple models. And then this script here, which I threw together, is just loading that MNIST training set and sending one of the test samples to the server. So I'll take a look at the response here, set a breakpoint, and then run it. If you're paying attention, you may have already guessed this. We're getting an error here because the model we're requesting also doesn't exist. So yeah, in the same way that we had to specify the name of the model, we need to do it here in this test script. And that's pretty much it. We get a 200, great. And in the response body, we should have the prediction for this particular input. I guess that was, the digit was an 8 from the test set. That's the main idea. So again, end to end, we saw a little bit of data prep, and EDA was actually handled a little bit by the code we put into that particular training task implementation. In real life, you would probably have, yeah, people working out of notebooks, maybe. Oh. And then registering experiments before moving into a phase of maybe training our automated training and evaluation. This is what Airflow did for us. Registering the model to our registry with Airflow, and then using ML Server for the deployment. A very simple setup with those components communicating directly with minimal orchestration on top of them. In a production environment, you would probably have some additional glue. Maybe you're using another pipelining tool to coordinate them. But I guess the main idea is communicated. We'll take a break here in case there's any need for discussion following from that demo. Let me know if there are any questions or there's something you want to take a closer look at. Otherwise, I'll just continue with wrapping up on a little more advanced demo, for example. Okay, if not, let's keep going. Moving on to a more intermediate project, we can say, which builds on top of what we've already discussed. So presumably with MLflow for keeping track of everything, Airflow for automating as much as possible, and ML Server for handling your deployments. you cover a lot of the requirements for an MLOps setup, but if you're working with a particular type of model and maybe you have other requirements, you may need to expand your use of this and introduce additional system components. Like I said, really high level here. And you'll also be able to find information on this presentation. But the main idea in this particular use case is actually, let me go to the presentation. Serving of language model adapters. So no doubt you'll all receive much more information on language models and LLM ops later. But this particular use case, working with language models and the technology of adapters, is somewhat interesting to think about maybe next steps following from that simple stack we just talked about. A language model adapter, I hope many of you are familiar with language models, large neural network architecture for often generating text, generating tokens. One thing you can do with these large models is also slot in additional trainable parameters, or during inferencing, dynamically swap in and out those parameters to adjust the behavior of the model. So in this case, as a step up from what we were talking about before, we're not just serving a single sklearn model anymore. We're now kind of needing to serve one big model and provide access to a lot of smaller models or trainable parameters, which can be added into that. This creates a complication or imposes additional requirements on our serving and also on our training, because we need now a higher degree of automation for training of these adapters. Furthermore, we're not just throwing around one single model now, we're throwing around a lot of different trainable parameters. And so orchestration of the training needs to go with our model registration. We want to be registering all of those adapters as well. This really simple diagram conveys a little bit of this idea. So previously we were working with just Airflow and MLflow. We didn't really talk about any kind of data store, but just as we would previously have just been serving one model, we'll have a single set of operations for maybe versioning and deployment of that base model, but now additionally also registering and versioning of our individual adapter components. This is just a very high level idea of how that would work, and it's rather abstract. But the main idea I want to convey is that even with the enhanced complexity of this use case, where we're training and orchestrating and in a way deploying many more models than in that simple example, it amounts to, in the intermediate case, of just scaling up and expanding your use of the existing technology. So just let the technology do the work. Just register more models to MLflow. So a bunch of additional adapters, for example. Just have more pipelines, maybe for automated training and also evaluation of each of your additional sets of parameters that you're considering. But furthermore, you may need to introduce other service components. So here I propose this middleware, which helps with routing of requests to each of those different sub-models, you could say, that we were mentioning earlier. Long story short, this simple set of tools, which I gave an overview of earlier, if used in the right way, can be very powerful even for more complex use cases if you have a higher number of models or unique demands on your serving or experiment tracking. Yes. And as mentioned, all of this information will be available in case you want to take a deeper dive on this topic. That's all I have for this session. As stated, it's a quick run through with high level look at everything. Here, in terms of additional resources, I'll go through it rather briefly. Reliable machine learning is a really great work, which gives a lot of great recommendations for thinking about MLOps in terms of software reliability. Here is a nice article about MLOps specifically. The code and slides you can find here. MLflow and Airflow, which we looked at in the demo. Their documentation is provided. And as mentioned earlier, depending on if you're working from a cloud provider or not, a lot of the concepts and technologies that I mentioned in this presentation may be abstracted or managed for you. So for example, Amazon SageMaker, which is quite popular technology for or platform for managing the machine learning lifecycle, handles a lot of this for you, and you therefore don't need to administer MLflow or think about integration between your serving and your model registration. Those kinds of integration and coordination challenges are managed for you and abstracted by the platform. So it's worthwhile to think about these in case your solution already has access to a cloud environment, and you could take advantage of some managed solution if you're, depending on what you choose, okay with a little bit of lock-in. Yes. That's it. Thank you for your attention, and let me know if you have any follow-up questions or would like to discuss any of the topics. We have a lot of time left over with the slot. I'll provide a link right now to this repo in case you want to, browse the code and slides yourself. I also have all that stuff running right now if we want to take a deeper dive on any particular component from the demo. Yeah, thanks.
All right, thank you very much, Christian. Thank you. Please help me give Christian a round of virtual applause like you were doing. There's also this fun Z button you can click, and you'll be, if you click on the Z button, you'll be dancing just like me. That's quite a fun way of participating as well. So yeah, I think, sorry, Lydia, you were also raising your hand. Maybe you have a question. Sorry, maybe.
Yeah, I mean, if we have time, I have a question. It's a bit of an opinion, maybe, on notebooks. Yes, no, a little bit, maybe, using them or not, like versioning them, or just, yeah, I'm curious to hear if you have an opinion on notebooks.
Yeah, like Jupyter notebooks, for example.
Yes, yeah.
Yeah. Yeah, I feel like this is in some ways like a controversial topic or a contentious subject, and it also depends on your organization. So like where I'm currently working, everybody is comfortable like implementing experiments directly in like code base, so no notebooks. Like for me personally, it can be convenient to work out of a notebook, especially for experimentation or prototyping. So from a, let's say, developer's perspective, I totally understand the advantages. And the only downside I see there is with respect to versioning, it can be a little cumbersome because versioning notebook files in your repository, for example, you can sometimes end up versioning the outputs of particular cells, which kind of sucks. So my opinions with respect to is it good for development would be sure, why not? If you can manage potential downsides through versioning. I don't know of alternative solutions for versioning notebooks other than versioning the files in your version control, or that's typically what I've done. Notebooks are also nicely integrated with the experiment tracking tools. So as mentioned or shown in that demo, we used Airflow to like do a little training for us, and then it created the experiment here. What you would often find is that some developer in their notebook, maybe your team has a particular wrapper around the MLflow client, and then imports that or uses the MLflow client in their notebook to just create experiment runs, and then you can adjust your notebook and run the cell again, and you'll end up with another row here. So in a lot of ways, notebooks and these kinds of experiment tracking tools work quite nicely together and provides a nice central hub to keep everything tracked. And then in MLflow's case, ultimately transition it more into production. So long story short, I don't have a problem with notebooks. I think it's great, especially from a developer's perspective, although you can run into challenges with versioning. And if you're looking into productionalizing, let's say code or especially the models, you would have to keep in mind what tooling you put around them to make that simple and transparent, because of course what you don't want is that somebody runs a bunch of experiments and then, oh, it was working well the other day. And then what? Let me go check my notebook, that kind of stuff. But these tools are, I think, designed to work hand in hand with those kinds of prototyping and model development workflows. I don't know if that answers your question comprehensively, or if you have any follow-up
absolutely.
thoughts.
Because I also feel like notebooks are a great start, but they sometimes feel to go against some of the MLOps principles of, like you said, like reproducibility, for example, and versioning. So, but so.
I guess you're right. Let's see a little bit if it's here. No, it isn't here, but often in your experiment registry, you would want to like log the code or maybe some kind of commit hash to the version that you're working from. Because you're right, even if you integrate with a tool like this, there's still potential that you lose the reproducibility of the results. So it would be important to think about when integrating your notebooks with some experiment tracking tool, like how do we identify from this result what was the code that produced it? Maybe you like log the script itself. I guess you can do that with MLflow or Sacred, or maybe you provide some kind of reference to it. That's a great point. Yes. Any additional thoughts, questions, or points worth discussing?
All right, then. Fantastic. Thank you so much, everyone. Thanks again, Christian, for your time and your efforts in this.